Hello, in this video I'm going to describe the fuel system in my Helicycle N750 Golf. Here's a schematic of the fuel system. The one thing I want to point out to you is the aux tank here. If you're over about, I think, 200 pounds, you can't have that aux tank because the CG gets out of whack and you're going to exceed the max gross weight of the helicopter. But if you're lighter, like I believe under 200 or under 180, somewhere around there, you'll have to check with Eagle on the exact number. Then you can put this aux tank in. And so in my case I did. I have then 4 tanks, which are all interconnected and gravity fed, and I can hold about 23 gallons of fuel. The helicopter burns about 13.5 per hour, so that'll give you an idea of the duration. And normal cruise, let's say 90 miles an hour, 80, 90, 100, depending how big a hurry you're in. That's how far you're going to be able to go. So starting at the top, we have one big tank that spans the whole width of the helicopter, and underneath it are 2 mirror image tanks, one on the left, one on the right, and then in front of those is the aux tank. So it's sandwiched between these 2 and the seat pan. Now the color code that I used here, these big purple lines are the ones that are used to gravity feed fuel from the top down to the bottom. All the fuel goes in up here. In the right side of the helicopter is the fuel flow, or the fuel tank entrance where you put your nozzle. And as you fill up the tanks, you're displacing air. All the air has to come back out that same way. So the way it works is as your fuel goes in here, it's going to drain right out the bottom to these 3 tanks. Depending how fast you're filling it, it may start to build up in this tank if you're filling it at a good fast rate. So something to bear in mind. You need to slow down a little bit, let everything equalize, let the air get out of the bottom tanks, and then you can add more fuel. So you can be fooled and think you've got plenty of fuel because this top tank is filled up, when in fact you really don't. You just didn't wait long enough. So as I say, the purple lines are the fill lines. These green ones double as sight tubes, so you can see what the flow, where the level is by looking to see where it sits in these little tubes, here, here, and here. And they also act to allow air to be removed from the bottom tanks, and they go back up into the top. So the 3 green ones are transparent so you can see them. This one serves the same purpose, but it's hidden away, and it's made out of rubber because you can't see it anyway. So as fuel goes into each tank, air comes back out, goes back into the top tank, and then back out the same way the fuel came in. Down here at the bottom, these 3 tanks all come together, gravity feed, into one common line that then goes off down the stream to the gascolator filter, through an electric fuel pump, through my my fuel flow transducer, through a master fuel cutoff, and then back to the fuel control for the engine. So I hope that makes sense. It's quite simple, and I'm going to show you a bunch of pictures that will clarify this, I think. So here we are looking at the left side of the helicopter. The seat pan and the cabin are not on, and you're looking at the very bottom of the top tank, this one here that goes all the way across, and you're looking at the outside of the left lower tank. Back here you can see the right lower tank on the other side. There's a gap in here of a couple inches. Some of the things to point out, that those purple lines that I showed you before, this is what they look like. They're big rubber lines. So this is how fuel gravity feeds out of this tank to fill this one. When you add the aux tank, it goes right in this area here. I hadn't put that in. And when you do that, you cut this line in half and you put a T in it. And so another big tube comes down into the top of the aux tank. So that's how that works. These are the sight tubes that I mentioned that allow you to look and see where the fuel level is. What I do is I squeeze the bottom of it and I look to see where that fuel meniscus moves up and down. Otherwise it's kind of hard to see, but if it's moving it's easier to spot it. So that gives me a firm indication of where I'm sitting. One of the things that is suboptimal here due to cost and complexity is this is the fuel quantity probe, and it sticks down like that. So the problem, of course, is that it's going to show full fuel until you've completely burned all the fuel out of the top tank. So you may leave with 23 gallons. It's going to sit there and it's going to say full fuel until you get down to about 13. Then that needle will come off the full peg. So that can be a little bit misleading, and it takes some getting used to. So most people don't pay a whole lot of attention to the fuel quantity gauge. Most of them tend to set a timer and go by time. The gauge does have a couple useful features. One of them is you can set a trip point to turn on a light on your instrument panel that says low fuel. And so I think I've got mine set around 5 gallons. That light comes on to warn me it's time to go home. Because remember, you're burning 13 or 14 gallons an hour, so 5 or 6 gallons isn't all that much. You don't want to be too far from an airport. So those are the major things to look at here. The other thing is the fuel line going back to the engine is this one right here. It's a braided line, and you'll see that it's clamped at regular intervals here, so it's not flapping around. Here's a view of the aux tank. So we're looking now from inside the cabin, looking straight back. If the seat pan were on, it would be resting against the front side of that tank. So it's directly behind your back as you're flying. And here again is the fill line going to this tank from that T that I mentioned. And here's the breather line, which is made out of rubber since you can't see it anyway, that goes back up to the top tank so that the air can be expelled out of this tank as it gets filled up. And the converse, as you're burning fuel out, air needs to get back in. Here we are looking again before the seat pan went on and before the cabin, so you're basically sitting looking backwards. And you can see the bottom of the left and the right lower tanks. This would be the right lower, and this is left lower. Here's that sight line and breather that goes back up. Here's all the gravity feed tubes that hook everything together. And again, I don't have the aux tank installed when I took these pictures, so there's actually another line coming in from the aux tank. All these get mixed together into one common line that goes out the bottom and goes off to my Andair gascolator. And I believe, I'm a little disoriented, but I think this is where the aux tank feed is going to be, because that has to go on last after everything else is squared away. Then you put that on. It screws into the back of the seat pan, and it gets jammed in between these two rails here. So rubber hose goes down to the Andair gascolator. From then on, everything is woven steel. So you go from the gascolator to the electric fuel pump, then it goes out of the picture to the fuel flow transducer, from there up to the master fuel shutoff valve, then it turns around and comes back out, and this is the line that I showed you earlier that goes back to the fuel controller. Is another view, again looking in from the left side. This time the seat pan's on. Here's the seat pan. You can see the aux tank is screwed to the seat pan, and I threw out the stuff that came with the kit, and I got a couple Marmon clamps. I'll show you a little bit of a detail here of how I mounted this tank to the seat with a couple of these clamps. And basically I think the mechanism that tightens the clamp is down here where I can get at it. So again, we're looking at the bottom of the end air filter. Up here we're looking at the electric fuel pump. Fuel comes out of these tanks, gravity feeds together, goes into the end air, from there by braided line through the fuel pump over here, or out of picture, into the fuel flow transducer, which sits on a pan that I made that bolts to the frame and holds some of my electronics and a couple other things down here. From there it goes up to the master fuel shutoff, and then back it comes. So this is the line going back to the engine, to the fuel control. And again, here's one of the, this is a breather slash sight tube, so you can see where your fuel level is visually. Here we are looking at the top of the aux tank, and this is the back of the seat pan. So what I did is I made some little aluminum pieces that bolted to the seat pan, and I used flathead screws here so nothing would protrude into my back, although it's going through several inches of foam. Didn't want to tear the foam up either. And then the Marmon clamp, I cut that in half and simply drilled a hole in it and bolted it on here. So I did the same thing on the other side. There's two clamps, left and right, and basically did the same thing here, top and bottom. So there's 4 of these things. And that's what holds my aux tank to the back of the seat pan. Here's just some more details. On the left, again, here's the end air, and I had to machine a mount for this thing so that it would sit vertically even though the frame is tilted. So you can see that the electric fuel pump is at an angle. It doesn't care, but mounted to this same bracket as my end air gascolator, which I wanted to be vertical, so I had to machine that. If you're curious, you can find that on my website. I modified it very slightly. The top and bottom I have little valves. You press the valve to open it. So this one I can press to let air out of the gascolator, and I've got one on the bottom which I can press to let fuel out if I want to check for water. Here again is a picture of a braided line going from the gascolator to the fuel pump. Here you can see kind of the area you have to work with. It's pretty thin back here, and you want to stay clear of all these moving parts. So you know, I made one T this way, and this is where the I believe the aux tank and the left and right lower tanks all come together here. Here's an example of some more fittings, and again, you know, this screwed directly into the side of the tank, and it basically leaked. So what I had to do on the right picture over here is come up with an adhesive that would secure that, seal it up, and make a good physical connection. And that turned out to be quite an exercise. These tanks are a class of plastic called LSE, low surface energy. And the common characteristic of all LSE materials is it's almost impossible to bond anything to them. It just doesn't stick. And so, fortunately, after trying several different ways of doing this with no success at all, I found a little company in Santa Rosa, California, north of me, that makes specialty adhesives. And this particular white adhesive you see here is designed to bond LSE plastics to metal. That was the good news. The bad news was I had to buy 2 tubes of this stuff, a minimum order of $100 to be able to solve my problem. So now that's been in use for coming up on 2 years now, and it's rock solid. I think if I yanked on that thing, I'd rip a hole in the tank. The bond probably would not fail, but it was expensive. Here you see a little more forward area underneath the seat pan, just to show you over here, kind of out of view, is the transducer for fuel flow. So fuel is coming out of the electric boost pump through there. It goes over to my master fuel shutoff, which I'll show you in a minute. It's also an Andair product. They're from England. They make some nice stuff. And then back again by a braided line all the way back to the engine. So that's all hidden from view. Once you put the cabin on, you can't get in there very easily. Here's a few detailed pictures. This is the Andair Master Fuel shutoff, and it's in the cabin underneath my left leg. This is what the fuel flow transducer is driving. It's an analog indicator, but it's a digital indicator with an analog needle on it, so it's very accurate. And 0 to 20 is really useful. At full rated power, at 150 horsepower, the engine consumes 17.5 gallons per hour, so it would be way over here. In flight, I'm up in the 12 to 14 area up here, so that worked out really well. And this gauge really serves as a poor man's torque meter or horsepower meter, because fuel flow is related directly to how much power the engine's putting out. More power requires more fuel. So I find this very useful. Over here is the filter inside of the Andair gascolator. Here's the gascolator over here. Incidentally, so this whole bottom, you see that crack right there? This whole bottom comes off. And the way that you keep it from coming off in flight is this pin has to go out, because it goes through both the fixed assembly and the movable bowl. The pin can't come out because there's a clip through it right here. And you see it's got a little, it's like a safety pin here. So this has to come out and around. Then you can pull the pin and pull that out, a little clip. Then the pin comes out. Then you have to twist this over here till this mark lines up with that one. Then this comes out. Then you can get at this. So the fuel flow goes through there before it even gets to the pump. And any debris gets caught up here. So this was during one of my regular inspections. You can see there's some minute little pieces of who knows what that the filter caught. It's a 10 micron screen, which is Teflon coated. And it turns out that the Teflon coating doesn't get along well with water. Net result is this thing keeps water out as well as particulates. So I like it. I don't think you can still buy this this small one anymore, at least not from Aircraft Spruce. It may be available directly from Andair in England. I think Aircraft Spruce has gone to a bigger one, which is fine. This is just the one I ended up with. Down here again is the valve that I can push and lock if I want to drain the tanks, for example. I have another pump just like this one. Incidentally, this is not a stock pump. I'll get to that in a second. So I took the stock pump and I use that to drain the tanks. So I put a piece of tubing here that goes through the pump into the tank that I'm going to drain it into, a barrel. I open this and lock it, turn the pump on, and I can drain all my tanks out that way. The difference between this and the stock Aux electric fuel pump is they're identical. They're made by the same company, except this thing has AN fittings on it. The other one doesn't. So I can come in with this modified one with my braided hose and screw it right on there. With the standard one, you can't do that. And here's that bracket that I had to make. I had to machine this thing. That was one of my first milling jobs that I did when I started this kit, like 4 years ago. I made this bracket so that this would sit vertically even though this is on a slope. And that's that. That's the end. So I hope that just gives you a rough idea, if you haven't got that far in your kit yet, some of the things to watch out for and how this all sort of goes together. So thanks for watching, and I hope you found that useful.